I'm gonna get our recording. There we go. Well, so hello to everyone. Thank you for joining. I appreciate you making time on this here in North Carolina. Lovely Sunday sunset. It is 8 p.m. here on the East Coast. I'm in North Carolina. My name is Whitney or Whit, and I'm a GMAT and GRE and EA instructor here at Manhattan Prep. These free prep hours are my favorite thing. I say that about a lot of things that I teach, but I love these free prep hours because they offer us as instructors an opportunity to teach the concepts that our students always want more about, but that we don't usually have time for in an online class or, in one of our bigger sessions. These are typically the topics that get reserved for one-on-one tutoring and like more small group sessions. And so just letting you know that I am so excited. I'm excited. So our topic this evening is going to be the idea of advanced statistics. Okay, so when I say advanced statistics, what that means, and so I'll give you a little bit of a screen share, the stuff that we are going to talk about will cover not just the basic descriptive statistics, although I will make sure that we are looking at some descriptive statistics, but in more detail, we'll be covering the concepts of weighted averages. We'll look at median. We'll look at skew, this idea of distributions that end up smushed to one side or the other. We'll use that to think a little bit about standard deviation, and then a little bit of a cautionary tale on mixed up or mixing different statistics with one another. And so I'm excited. This will be fun. If you have any questions, by all means, just like type them in the chat window or hop on the mic. I'm happy to have either. I love the jump in. So we'll start with a review of our stat fundamentals. So we just need some basic formulas. Can somebody grab average for me? So who can tell me what is the formula for a simple average? How do I calculate an average? And again, you can type it. You can grab the mic, whichever you'd like. And it should be so that you can chat with everybody. So just kidding. There we go. Now it should be that you can chat with everybody. Type it in the chat window or put it on, grab the mic. What is the formula for average? Yeah, very nice. I love that. Okay, so Alice came in with the average is the sum divided by the number of terms. Okay, that's our formula for a standard, simple average. I take up all the numbers I have and I divide it by that number of terms, however many there are. Yeah, cool and nice. Samuel, I saw that in the Q&A. Beautiful. All right, what about median, y'all? What about median, y'all? What's the median of a set of numbers? And again, feel free to grab the mic or type it in the chat window. What is my median? Very nice, very nice. So cool, and I got this from a couple of folks. Thanks, y'all. So if I order a list, it is going to be the middle term of an ordered list. So if I have the list of numbers 1, 2, 3, 4, 5, the median is going to be 3. Now, if I have an even number of terms, so let's say that I end up erasing 5, then the median, once they're ordered, is the average of the middle two. So the median in this case would be 2.5. Beautiful, beautiful. All right, my range, we're almost there. What's my range? It is, once again, ordered. It'll be the maximum value minus the minimum, or the highest minus the lowest values in a set. Beautiful. Now, standard deviation, there is a formula. We do not ever need the formula for standard deviation, thank goodness. But conceptually speaking, what is standard deviation? What in the world is standard deviation as a concept? Alice nailed it with the like technical definition, the distribution of terms relative to the average. I love that. What we'll use as a little bit of a maybe a lazier language for it is that the standard deviation is the spread. It's how spread out a set is. And in many cases, at least for the purposes of this test, we can often get at a rough idea from the range. So if something has a really spread out range, there's a decent chance that it's going to have a high standard deviation. If you've got two sets that have kind of the same range, now what we look for is what's happening inside the set. So are the numbers inside the set all sort of scattered? Are they all very clumped into the middle, which would mean high accuracy? The more clumped towards the average, the better. The more of our points are clumped out at the ends or spread out, the more deviation we have, the more variance, the more deviant the set. Okay, beautiful, y'all. Okay, so these are our fundamental stats. We are now going to move into some of my all-time favorite. So we're going to start with some visual representations of weighted averages. Okay, so let's start with this first question. I want you to take a moment and then type to me. And for this one, I'll set it to just type to me. I want you to tell me what you think the answer to this question is. And we'll take about, I don't know, a minute or so to answer it. And I'll put a little timer up. Maybe 45 seconds or so. What is the answer to this question? All right, so Sam, if you don't mind, how did you come up with 95? You got that pretty quickly. That was awesome. Where did that come from?
I mean, it doesn't really matter how many quizzes it are. If it's two quizzes, on one she got 100, the other one she got 90, so that's 95 would be the average of those two.
Nice. So what we're looking at when we start to think about, or what I want you to think about when you think about averages, is that averages, be them these like simple sum up a bunch of stuff, or what we're going to start calling weighted averages. Averages are all about proportionality, or it's like the ratio of my inputs. And so I'm going to show you a visual for averages that we're going to come back to a bunch tonight. And so the visual I use, and there are a few different ways that this gets talked about. I know in one of our books, we talked about it like a teeter-totter or like a seesaw, or I'm going to kind of just point to this visual, and we'll talk a little bit about this, playground game of tug of war, kind of thinking about like pulling in one direction or the other, or maybe we can think of it as a little bit of an over under. But in general, I like to think of weighted averages as this balance where I am trying to figure out what each side of my average, like in this case, I've got a score of 100 versus a score of a 90. What do those weigh? How much impact are they bringing to my overall score? So the way this little image is going to work is that it has roughly five sort of areas. So it'll have an area on either side. So there'll be two boxes on the left, and there'll be like two boxes on the right. And these represent my inputs. So when we start to think about weighted averages, and we're going to see several examples, I want you to start to look for the quality of having like two subgroups that eventually get combined. Okay, so that's where we get our weighted average. We have this subgroup, we have this subgroup, and then we know something about them together. So on one end, I'll have, let's call this group A. And on this end, it'll be like group B. So there's a stack of tests in category A, a stack of tests in category B, and we're trying to balance for the overall score. That means that there will also be a number kind of here in the middle somewhere. And we'll talk about what to put there and when. Now, along the top, the boxes in the top are for the value I'm averaging. So in this case, it's score, it's quiz grade. But the value that we might be finding the average of could be average age or average weight or average concentration if we're talking about mixtures, the average price, right? The average height, whatever, all the things. So what goes across is the value I'm averaging, and what's going to go down at the bottom will be the amounts of each subgroup. And then I often like sort of toss a little total in over here as well. We'll see space for that in a second. So this is overkill for this problem. I get it. But we're going to use the same image when dealing with two different sort of families of these weighted average problems. And I want this method to be able to carry you no matter how hard a weighted average problem becomes. So in my category A, I normally, like most of the things we're averaging, right, are going to have a numeric value to them. And so I try, when possible, to put the values of the things I'm averaging from least value on the left to greatest value on the right, just because that's how I look at a number line. But in this case, she's got some tests where she scored a 90. And she's got some tests where she scored 100. So I'll fill them into those boxes. I want to know what the average score is. So that box is going to remain empty. And now what I know is that 50% and 50% are going under each. Or a half and a half. Or she has one test and one test, or 10 tests and 10 tests, or who knows, whatever. The point though is that these two bottom numbers, these like weights, that's what these are. These are the weights of a more traditional fraction. These weights are pulling on a middle overall average. Because these two weights are pulling equally, the actual average is going to sit dead in the center. It will be right here at 50, right? At that 50% mark, halfway point. And so our average is 95. Okay. All well and good. So what happens then when I change this problem? And I change the balance of what she got, how many hundreds and how many 90s she got. Now what do I have to do? So once again, we'll take about, for something like this, I'd want you to be able to finish this problem in about 45 seconds. That's how fast I would want something like this one. We'll take about a minute. All right. So Alice, how about you? How did you get to an answer so quickly on this one? Oh, and I think you're on mute. You got there very quickly. Oh. Oh yeah, that's fine. You're welcome to type. Totally welcome to type. Did you use the sort of side-by-side line? I was going to say, feel free to hit enter sort of frequently so I can follow you along instead of one big paragraph. Yeah, okay, I love it. So the math is pretty easy on this one. But I want to practice with our little side-by-side and see how even when this shifts, we can come up with a solution. So if I build out, I've got this time of my 90s, I had 75% of them there. So 75% on the end with my 100, I have 25%. But what I'm going to do is I'm going to adjust. All I care about is not the 50 and the 50. I care that I can see the simplest ratio of these. So for the one we did up here, the simplest ratio is sort of that 1-to-1. For these, the simplest ratio would be to take these both down to a 3-to-1. So I'm in a 3-to-1 ratio, which means I'm going to be pulling my average to the left towards 90. So I won't be in the middle anymore. I'm going to pull left. Now, on the test, that might actually be enough. I'm going to look at my answer choices, and if that gets me down to a single answer choice, that it has to be somewhere between 90 and 95, I'm going to pick the answer and move on. Okay? But I know that it'll be to the left of the midpoint. Now, here's where you can use this kind of tug of war or pull even more effectively. So I know that right now, my weighted ratio is of the weight 3 parts 90, 1 part 100, for a total of 4 parts. Okay. So what I'll do is I will break this line into 4 segments, and I'll show that this 90 has pulled the average in its direction 3 times as far as the 100 has pulled the average in its direction. So my actual answer will be 3 times closer to 90 than it is to 100. Now I just have to figure out what these intervals represent. And a 4 interval between 90 and 100 would in this case be 92.5. Okay, so we can use this kind of like tug of war with the ratio. So let's try one more. I want you to try that same sort of tug of war ratio. This time we just move the numbers to 80-20 and see how they kind of pan out. And then we'll just check in quickly and see how it went. So let's, again, take about 45 seconds. All right. So we'll set it up same way again. I've still got my 90s on the left. I got my 100 on the right. This time my percentages changed. I've got only 20% down here. I've got 80% up here, which if we reduce, right, I've got 2 to 8, which is the same as 1 to 4. This time it's 1 part 90, 4 parts 100, for a total of 5 tests. Now, this math is simple enough. You could just add them up, right? 1 times 90 plus 4 times 100 divided by 5, and there's your answer. But I want you to also see that if I break this line into 5s, doesn't have to be perfect, but a line of 10 from 90 to 100 broken into 5s means that I go 2, 4, 6, 8, 100. So this would be like 92, 94, 96, 98, and so on. I know that the answer has to be 4 times closer to 100, which means 1, 2, 3, 4 times closer to 100 than this distance towards 90. So I like to, again, think of this like where the actual weighted average lands is sort of like the flag in a tug of war. And so the 100 in this case was able to pull the flag in its direction 4 units away from the 90, right? It got it 4 units in its direction, pulled away from the 90, whereas the 90 is only able to hold it away from the 100, the 1. And so our average is 98. So I always start with okay, the 100 is more heavily weighted, so the average is going to be to the right. And now to get really specific about where that average is going to go, it'll be on this kind of line. Okay, so we've got a situation where in this kind of tug of war, where there are 5 holes, right? There are the holes for input A, the holes for input B, and then where we think about this middle number. If what's missing is the middle number, so if we know both of our inputs, if what's missing is the middle term, we can simplify the ratio of the inputs, that bottom number, and we can do the math if it's fast or easy enough to do without a calculator, or we can start practicing with this little kind of like tug of war splitting up. Now, I'm going to recommend the practice because what comes next is the harder, mathematically and just like computationally, the harder version where now we do know the middle, but I don't know one of the end points. Okay, so let's try this one. And again, maybe consider how would it fit into this same container where what goes across the top is the quantity we're averaging, which it's nothing has changed. We're still in the tests. Quantity we're averaging. And the bottom would be the weights, or how much each one pulls on. And make sure you're reading the question carefully. What are you solving for? Exactly. Take another 15 seconds or so. Yeah, you're not alone. I promise. You're not alone. All right. So I have 2 scenarios. I have her getting a 90 on some of her tests, once again, and 100 on the rest. So she gets 100 on 6 tests. She gets 90 on some unknown number of tests. And then she gets a 96 overall. So that balance, that over under, this is where it really shines. So the 96 is 4 away from this 100. One way to think about this as sort of the storyline is that every time Anna got 100, she was getting 4 points over the average every single time. 4 points over, 4 points over, 4 points over, 6 times. For what turned out to be an overage of 24. So every one of those 4, 6 times. So this is one way to think of it. We'll also do the sort of ratio, which I like. So this one is up by 24. On this other end, every time she got a 90, she was down by 6. She was down by 6. And so the other way I can think about this is that in order for 96 to actually be the middle, the 24 extra points that she gained from those hundreds has to be balanced with 24 under points on the left. So if I'm losing 6 points every test and I need to lose 24 points to weight out, to balance out that positive 24, it's going to take me 4 tests to accomplish that for a total of 10 exams. That's one way. The other alternative is to kind of go with what we were already doing and say, all right, each one of these distances on the left and on the right represents how strong that side was. So the 100 side has been able to pull 6. So I'm going to write this down here, which turns out it actually already equals the number that's there. This 90 side has pulled, so I guess a way to, let me draw this arrow a little bit better. A way to think about the 6 or this 100 is to think that the 100 has pulled the average, its direction 6 points, right? The 100 has pulled the average 6 points in its direction. The 90 has only been able to pull the average 4 points away from the 100. So those 4 points are going to be attributed to the 90, while the 6 points get attributed to the 100. I've already got a situation where that equals, so this must also be a 4 for a total of 10, okay? So hold tight with me. Let's do this 2 more times, okay? So we're going to keep practicing this same, what happens when I know the middle and something about the ends, how do I apply this over under to figure out a missing piece? Let's try this one. A little trickier, huh? Good, 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 good. So let's try it again. I've got my 2 ends. Send me your answer either privately or to the whole crew, either one. So I've got that she gets a 90 on 10. And she's got 5 more tests over here, and I don't know what she needs to score on them. But I want to earn a 92 quiz average. So I'm just going to stick the 92 here in the middle somewhere. Now, I should say that I know that the 92 is going to be closer to the 90 than it is to this because the 10 tests under 90 have pulled it its direction. So I know that this is going to be to the left of halfway. I'm going to reduce my inputs down to 2 scores of 90 for every 1 score of whatever the heck this thing is. That's for a total of 3 exams. So I want to break this line into thirds. So it would be the first, second, and the third, which means if this is a 92, it goes 90, 92, 94, 96. Okay, one more. Let me try it on a more full official question. Here we go. Give this one a go. All right, starting to see some answers coming in. This one's a challenge, right? So this one is a super challenge. If I build out my little slider, I've still got 90s and I got a little box. I got 90s and 100s. 90s on one end, 100 on the other. Now I don't know what numbers go in these boxes. I do know though that the total, the actual total, is 16. So when I add this box plus that box, it's going to give me 16. So that part I do know. So the beauty of this method is I go, okay, the 90 was strong enough to pull the average its direction 3. The 100 was powerful enough to pull the average its direction 7. Oops, and I should have put this down here. Sorry, this should be a 3 down here. And on this end, I've got a 7. For a total of 10 tests. That's kind of the math piece that I've got here, right? So I took 16 quizzes. Her overall quiz grade was a 97. On how many did she score 100? I've got to figure out, and I think I might have given y'all a little typo. But what I've got to get is I need to move from this. Maybe I should actually. I think I gave y'all a typo. Just kidding. This is supposed to be a 5. Right? So this is supposed to be a 92. My apologies, y'all. This is 92. There we go. And so this is supposed to be a 5. So the 100 pulls it 5 its direction for a total of 8 quizzes. But what I know is that there's actually supposed to be 16 So I double everything. So there'll be 6 quizzes where she got a 92 and 10 quizzes where she got 100. And so I got to do the little pull each direction. So no wonder why that one was like tricky. Super tricky. My apologies for that one. Well, so then let's try one on a question that's like official, right? Or official like. Yeah. So here you go. Here's a full question with actual answer choices. And I'll set your timer. Our goal is like 2-ish, 2.5 minutes. Very nice, y'all. Very nice. So I can build out my table or my little system. So I've got one kind of cereal that's 55% fiber. That's my fiber X. And I've got fiber max that's 70%. And Sheldon's going to combine the two together in an amount that would land us at 65% fiber. What that means is that X has pulled the average its direction 5, whereas Y, or excuse me, max has pulled the average its direction 10 for a ratio of 1 to 2. Fiber X to fiber max. Or I could see that fiber max, it's definitely an average closer to fiber max. So fiber max will have a higher number than fiber X, and so I can eliminate D, E, and A. And then between the two, sort of take a stab. But if I can see this as 5 pulled this direction, 10 pulled this direction, boom, I'm done. It is a ratio of 1 to 2. Very nice, y'all. Very nice. Okay. How are we feeling? Pretty good? Seems all right? Maybe. Cool. All right. So up next, we're going to jump in to a topic of median. That's our next big fun one. Let's talk median. So we know that in general, median is going to be the physical middle of a set. That said, sometimes the test will ask you, and so we're going to look at IR for a second, our integrated reasoning section. Sometimes the test will ask for the median in a set of numbers that isn't obvious. Right? So this is an example of a graphical interpretation IR question. For graphics interpretation, there'll be 1 or 2 sentences. Each will have a blank in it, and they'll each have a drop down. The drop down would then have either 3 to 5 or 6 answer choices. So what I'd like to do is let's take about 3 minutes because the typical time for an IR question, so this is that integrated reasoning section, is about 3 minutes on average. So we really only have about 2.5 minutes, but it's good to skip a question so that we can prepare to have more like 3. So we'll take about 3 minutes to see how you solve both of these, and then send me your answers when you think you've got them. So that's about 3 minutes. And I had a great comment in the chat. It's like, is it fair to like not really do any math on these problems? It is. There are going to be times where we don't really have to do math. The key though is understanding how to read median off of a table, a chart, or a graph. And so what we need to think about, let's just first look at the first question. The second one, we're going to talk a little bit about skew to get our answer. But for this median, so of the owner occupied housing, the median household size. So if you think about median, right, what I would do to find the median of anything is I have to order. So to find the median, I have to order the set by whatever characteristic I want to take the median of. So in this set, I'm taking the median household size in number of people. So what I would do is I would start listing out where the median would be by saying, okay, I'm going to take, here's this like insane number of houses, but I'd take the first person, that's the smallest, is a 1-person household. I'd start listing out 1, 1, 1, 1, 1, 1. I'd do that for 21% of these 75 million houses, 76 million houses. So I'd be listing out just a whole massive number of these. So I'd list out 21% of my sample as one, 21.6%. Then I'd start listing out a massive, even bigger list of twos. And then I keep going. I get some threes in there. I keep going, some fours in there, and then eventually some fives, and so on and so on and so on. So once I have a one family household all the way up to my 7, 8, 9, 10, I mean, there may be a few 25-person households, who knows, right? So once I've got them all lined up, I will then go find the middle. And the middle is the place where precisely 50% of the people are on one side, or 50% of the items are on one side, and 50% of the items are on the other side. So if I list all of these numbers out, I'm looking for where the 50th percentile would land. Well, the first 21.6% of observations will be ones. The next 36.3% of observations will be two. And that takes me now up to 57.9% of my observations are ones and then twos. So the median household will be in the middle of all of those twos. The 50th percentile will land inside the category of twos. And so the correct answer for this first one is B. Okay, definitely tricky. Definitely a little tricky. Okay. Okay, so to talk about the second one, the second question in our set was the average is how much bigger or smaller or the same size as the median. And the average would mean that I would have to take 21.6% of that, and 36% of that, and 16% of that, and 14%, and add them all up and then divide by that total number of houses. No way. Absolutely not. That cannot be what the test wants us to do. And the fact is that it doesn't. It does not want you to do that at all. In order to solve this next piece, we need to think about what happens when a set is skewed. Okay, and so what I mean by skewed would be that there's more on one end or another. All right, so let me give you a couple of very simplistic looking sets so that you can see what I mean by symmetric versus skewed. So if I have a set, let me grab another one of these. Here we go. Okay, so we'll talk about average and median. So here we go. If I have a symmetrical set, so I have 2 observations at 10, I have 3 observations at 11, and 2 observations at 12. So let's pretend these are people at certain scores on a game. So I had 2 people score a 10, I had 3 people score an 11, and I had 2 people score a 12. What I know in those cases is that when I have a symmetrical set, so it doesn't have to be like evenly spaced or anything fancy, but when I have a set that is symmetric, the average and the median will be that middle point and they'll be equal. Once I end up in a skewed distribution, right? So instead of having 2 at 10, 3 at 11, and then 2 at 12, I now kick out 2 further. I now send these over to the right, and these are what we would call outliers. So I still have the 10, if I had kept my 10, 11, 12, all of that would have sat nice and neatly, but all of a sudden now I've slid the 12 out towards the 13. So that's going to be my outlier. So now let's think about what happens when we think of an outlier. So let's say we've got everybody living in our town and we all make whatever money, like we all live in whatever house we live in, and we have the average housing value in our little town. And then let's move an outlier in, right? Jeff Bezos moves into town. What is that going to do to the median versus what is that going to do to the average? So if we think about the median as being the physical middle in a set of numbers, moving the highest point all the way out into the stratosphere doesn't change my median. My median is unaffected by outliers. My average, however, right, if I now have my little town and this super duper expensive house, right, kind of moves in, that's going to pull the average housing value up. And so what we end up with in a skewed distribution is that the median stays where it was, but the average is pulled up towards outliers. So our average is pulled up towards the outliers. And if we think about this from a broader distribution, so as you start to look at this when you go to business school and you start to think about your stat classes and what this means, is that what we want to recall is that the median is going to be the halfway point, right? Where half of the observations are on the left and half of the observations are on the right. And so it's going to sort of stay hugged towards wherever the bulk of my observations are. But my average is going to get pulled in whatever that tail or whichever end has observations that are further afield. They get pulled further and further out in that direction. So if we go back to our question of what's the story about average versus median? Well, I know that the median is a 2-person household. That's my median. If I look, I have at 1, right? So if I started to look at my people, I got 1, 2, 3, 4, 5, 6, 7, 8, on and on and on. I have 21% of people out here. I have 36% of people out here. Massive. I then have 16% of people out here. I have like 14% of people on the 4s. And then once I get out here, I have like 6% of people on the 5s. I have 2.6% of people on the 6s. I have like, 1 and 1 and something way out here. So if I look at my distribution, right, and it sort of tails off over here, that end is my tail. These are my outliers. And so if these little suckers over here are my outliers, the median will still sit here, but the average will be pulled towards those outliers. So the average in this case will be higher or greater than the median. Kind of cool, huh? Yeah. Okay, so that's this idea of skew, this pull. So last but not least, before we call it a night, we want to talk about the last kind of weird and advanced topic, which is how we handle standard deviation. And so in general, we want to think of standard deviation as being, again, how spread out our numbers are. Yeah, so like how spread are the numbers across my little, distribution, so to speak. But there are a couple of additional rules that you want to be able to handle when it comes to standard deviation, a couple of factoids. Yeah. So let's start with a little quiz. And we'll do the first one. So let's take about 30 seconds and see. All right. So if we want to start putting these in order, the highest standard deviation is going to be the set with the greatest spread. So the ones that are the most spread out would be set A. That's going to be our highest. We can kind of peek at this range from 1 to 14 as being pretty spread out. Our lowest would be the one that has a standard deviation of 0, where there is no deviation. Yeah. And then our second highest would be D. So this would be our highest. This will be our second highest. This would be our third highest, more compressed. And then this would be our fourth or our lowest. Note that the size of the numbers themselves doesn't matter. Right? The size doesn't matter. What matters is how spread out those numbers are. Okay. Yeah. Oh, no worries. That's perfect. Okay. So now what do I do with a question like this? Nice. Nice, nice, nice. Excellent, y'all. So in this situation, if we have an average of 9, then anything that is 2 standard deviations above the mean would be 9 plus 2 times whatever 1 standard deviation is. So 9 plus 6.5. Oops, that's not a plus 5. 6.5 is 15.5. Okay. Last but not least, for our standard deviation, our weird rules. Let me toss one more in here. All right. All right. So beautifully done. The thing to note about standard deviation is that it moves along with what's happening or what's being adjusted on the set. If I take a bunch of numbers and I add the same thing to every number, so if I took this set, right, like let's take any one of these. If I took this set 15, 15, 16, 16, 17, and I added 10 to all of them, I would have 25, 25, 26, 26, 27. There's been no change in the spread. The spread has been unchanged. So adding or subtracting the same thing to every number in a set doesn't change the standard deviation. However, imagine the set 1, 2, 3, 4, 5. If I multiplied everything in the set by 2, my new set would be 2, 4, 6, 8, and then 10. A much more spread out set. And so if I multiply by a number greater than 1, right, I expand my set out. If I multiply by a number less than 1, I shrink, so divide, I shrink my set in. And so if each value in the set has 4 added to it, that has no impact. But then multiplying each value by 1.5 would increase the standard deviation by 1.5. And so the standard deviation in the new set would be 2 times 1.5, or in this case, 3. Very nice. Okay. So our last question is a little bit of looking back at where we started, some weighted averages, but not quite a GMAT, right? This one's going to be sort of a choose all that apply. But this is a tale about what one statistic tells me about the others. Yeah, and so give this one a go before we call it a night. All right. So if we set this up and we look at our earthworms and we have an average of sample A, an average of sample B, and then combined, we're back in the world of weighted averages. So the average length of those in A was 2.4 inches. The average length of those in B was 3.8. The overall average of the two combined is 3. That pulls to the left 0.8. That pulls to the right 0.6 for a ratio of amounts as 8:6 or 4:3, which means there are more earthworm A's in the sample. It's closer to earthworm A, right? That distance is closer. And so A, we can show is true, but here is the cautionary tale. Without information such as sets are consecutive integers or evenly spaced, we can't say anything about one metric, one descriptive statistic from the others. So if you tell me about average, I am probably not going to be able to tell you much about median or range. If you tell me about range, I'm probably not going to be able to tell you about average or median or standard deviation. And in fact, if you tell me about any one or even two or sometimes even three, if you tell me about all of these other ones mixed together, I still can't pull one that's not those from it. So there's a reason why in the world of statistics, we have a host of descriptive statistics: average, median, range, standard deviation. We've got quartiles, right? The reason why the reason why we have so many of these is because they can't just be created from one another. Right? We know about each one, from each one, some aspect of our set as a whole. And so just because you tell me about one or two of them does not mean that I can derive the others. So in these cases, knowing that there are more earthworms in sample A with a lower average, I still have no idea, because of outliers, what their median or their ranges are. No clue whatsoever. Yeah. Awesome. All right. Y'all have been amazing. Y'all have been amazing. So keeping in mind statistics, right? Think about what it is that you want to practice, because these statistics show up all over the place. Coming up with averages, weighted averages, and so on, show up not just in the quantitative section, but also in the integrated reasoning section, not just on the GMAT, but as you move forward into your B school career. So I am excited that we got to talk about some of these more advanced topics this evening of, stat and median and all of the above. But just to keep you in the loop, if you ever need us, we are always here on our free prep hours. You can sign up for them on the site by going to manhattanprep.com and checking out all of our free resources. You can get free student center access so that you've got a syllabus with part of our starter kit with a free practice exam. There you can also, underneath our free items, sign up for a session 1 of any one of our courses, absolutely free, no requirements at all. You can come and attend and ask questions and hang out. We've also got a ton of online other sessions just like this that we host on a weekly and monthly basis. So again, check us out, manhattanprep.com. The link will be below if you're watching this on the recording, or if you're watching this in YouTube, check out the entire channel of free prep hour videos. By the time this video came out, so by the time you're seeing this one, we're close to 100 plus of them at over an hour each. So hundreds of hours of video to talk about all the different topics that you might want to cover as you practice for the test. So keep us in mind when you are looking for some help with trying to get yourself organized while you study. And again, my name is Whitney, or Whit. It's been a pleasure to get to hang out with y'all this evening. I hope you have a wonderful rest of your weekend and an amazing time studying. Best of luck with your exams. And it's been a pleasure to get to work with you. Take care, friends. It's been awesome.